Good evening, everyone. So welcome to my YouTube channel, Master Forum. So today we are going to see second lecture on power series. Today we'll study what radius of convergence of a power series. Okay. So before defining the radius of convergence, we would like to do one result, that is, you can say theorem. Let this series be a power series. Okay. If if this power series converges at some x is equal to c, where c is non-zero, then the then the power series if the power series converges at x is equal to c, where c is non-zero, then the power series then the power series then the power series converges for all x such that the absolute value is less than c. Okay. Absolute value of x is less than absolute value of c. Okay. If the power series diverges at x is equal to t, then the power series then the power series diverges for all x such that absolute value of less x is greater than absolute value of d. So I am calling first part A and this part is M because these are two different parts. So I am calling it part A. Then so I am calling part A if if power series converges at this, and second one we are calling this part B. Okay. We are calling this part B. Okay. Part B. So let's prove it. So, let's prove it. Part A. Let the power series summation n goes to 0 to infinity a n x to the power n be convergent at x is equal to c, that is non-zero. Okay. Then actually this series is convergent. So this implies a n c n converging to 0. Okay. It means what? It means what? There exists n belongs to n such that a n c n power 0 is less than 1 for all n greater than capital N. Okay. So what does it mean? It means that a n c power n less than 1 for all n greater than capital N. So this implies a n is then 1 upon. Now let x be such that okay, then this implies x to the power n is less than x to the power. So from 1 and 2, we have a n x to the power n, that is a n x to the power n, okay, that is less than c n upon that is less than, but from 2 this is less than 1, from 2, okay. So from 1 and 2 we have this one, okay, from 2 we have this one actually. So what does it mean? It means a n okay, it implies a n x to the power n that is less than equal to x that is less than. Okay. Now this series converges. So this is true. 4. Now, Now this series summation n goes to 0 to infinity x upon p to the power n converges because it is a geometric series having common ratio x upon c that is less than 1. That is less than 1 because if you take here, so what does it mean? It means, so what is it meaning? It means that x upon c less than 1. So common ratio is less than 1. Okay. So above thing you can say this one. So this is actually, so I am writing this here. So we have this one. Okay. So we have this one, and because this convergent, because it is a geometric series with common ratio this. Okay. So by comparison test, this series summation n goes to 0 to a n x to the power n converges because what is a n x to the power n, that is less than x on c to the power n for all n greater than k. So by comparison test it converges. So this implies converges. So this implies this series converges absolutely. Okay. So this implies this series converges for all x such that okay. So this part is proved. Now second part we are going to prove. Let this series be divergent at x is equal to t. Now let x be such that x is such that where absolute value of x greater than absolute value of t. Now, if possible, suppose that the series summation n goes to 0 to infinity a n x to the power n diverges at x such that x greater than d. Okay. Then by part first, if possible, suppose that series converges at x converges. Then by part A, the series also converges at x is equal to t. Okay. Also converges at x is equal to c, c not equal to 0, and okay. Now series converges at x is equal to d. Now we can choose. So in this form, you do one thing actually. So yeah. So suppose series converges uh, at x such that x greater than. Now then choose x naught such that then choose c such that we can choose this so that by part first, by part A, the series summation n goes to 0 to infinity a n c n converges by, because at x it converges and x is greater less than absolutely less than x, so it converges by part A. Next d value is d is now d value is less than c, again by part A, the series summation 0 to infinity a n a to the power n e to the power n converges, which is a contradiction. Because at d series diverges. Hence, therefore, the series diverges for x such that absolute value of x is greater than absolute value of d. So this is true. This result is okay. Next, what is the radius of convergence? Radius of convergence. So similarly, we can write a result corollary. You can see corollary. Let this series summation n goes to 0 to infinity a n x minus a to the power be a power series. Okay. So you can write Cn here. Be a power series if the power series converges at x is equal to c such that c is not equal to a, then the power series is converges for all x such that x minus a is strictly less than x c minus a. Okay. This can be proved in a similar manner. Okay. If we change the center, then the generalization of above theorem will be this corollary. Okay. Second, if the power series diverges at x is equal to t, then the power series diverges for all x such that x minus a is d minus a. Okay. So this can be proved in a similar manner. Okay. Now, by using this, we are going to define a radius of convergence to power series. Radius of convergence radius of convergence radius of convergence of a power series. Given a power series there exist unique r greater than equal to 0 such that the series diverges for all x such that x minus a, then there exists unique smallest, there exists unique, or you can say there exists smallest only, it will be enough because the smallest number is always unique. Given a power series, there exists smallest, there exists smallest, given a power series, the smallest number are greater than the smallest are greater than equal to 0 such that the series diverges for all x such that x minus is greater than or then this R is called then this number R is called radius of convergence of the power series. Okay, radius of convergence of power series. Given a power series, the smallest number are greater than 0 such that the series diverges for R. This number R is called radius of convergence. If no such number exists, if no such number so I would like to correct my statement. Given the power series, given a power series, if there exists smallest number such that this happens, then this is called radius of convergence of the power series. If no such number exists, then we say that the power series has infinite. We say that the radius of convergence, we say that the radius of convergence of the power series is infinite. Okay. infinite. And we write R is equal to infinity. Because R is radius of convergence, so if no such number, we say R is equal to infinity. Radius of convergence is infinity. For example, you see this example. Summation n goes to 0 to infinity minus 1 to the power n minus 1 x to the power n upon n. So this is 1 minus 1 minus x upon 2 plus x upon x square. So what is this? So this is x minus x square upon 2 plus x cube upon 3 minus x4 upon 4 like that. Okay. So in last lecture, we have shown that what is un? Un is x to the power n. Okay. So this is un. And what is un plus 1? That is, so we calculate un plus 1, un that is going to be n upon n plus 1. Okay. So what is the limit of this? This is going to be, okay. We find out that this series diverges in last lecture. The series diverges for x such that x is greater than 1. Okay. Therefore, x, therefore, n converges for x such that, so what does it mean? This implies r is equal to 1. 1 is the smallest number. This implies 1 is the smallest number such that the power series diverges for x such that, so what is the meaning of this? The radius of convergence is, this implies the radius of convergence of the power series is 1. It means r is equal to 1. So this is the answer. Okay. Now, second one, example 2. series summation and goes to 0 to infinity. You take this x minus 1 to the power n upon factorial n. Okay. Then what is this un? What is un plus 1? So what is un plus 1 upon un? So that is x minus 1 upon n plus 1. So take mode, what will be this? Will be this. So limit. So this is going to be 0. Okay. So this is x minus 1 limit. This is 0. Okay. So what does it mean? It means by ratio test. Yes. So this is one ratio test. The series summation n goes to 0 to infinity x minus 1 to the power n upon factor n converges for all x belongs to R. It means there does not exist any number R such that that the power series diverges for all x such that x minus 1 greater than R. So this means the radius of convergence is infinity. Radius of convergence of this series of the power series is infinity. I means R is infinity. Okay. Now we see next example. Example 3. Then what is un? And what is un plus 1? This is un plus 1 again. So what is this n plus 1? So what is limit and tending to infinity? This is infinity if x is not equal to 2. Okay. And this is 0 if x is equal to 2. So this implies by ratio test series converges at x is equal to 2 because limit and tending to infinity. un plus 1 upon un is equal to 0, that is less than 1, or x is equal to 2. And by ratio test again, limit, by ratio test again, the series diverges at x such that x is not equal to 2 because limit that is greater than 1 for okay. So if x is not greater than equal to 2 means what? So this implies, so what is the meaning of second statement? This is the meaning. It means series diverges for all x such that x minus 2 is greater, because x is not equal to 2, the series diverges. So if x not equal to 2, it means x minus 2 difference is greater than 0. Okay. So what does it mean? What is R? R is 0 here. So radius of convergence is 0. So this implies radius of convergence is 0. It means R is 0. So today's lecture up to this. If you have any problem related to this, you can comment on my YouTube channel. Like, share, comment and subscribe my YouTube channel. So thank you very much for today's lecture. Thank you very much. We will see you for next lecture.